Okay, so we have to find the transfer function for the following circuit and then obtain the zeros and the poles for it. So, hold on, okay. Wait, give me a sec, guys. Okay, let's start now. So, let's get VO T over I of T. So we're gonna start with that. So we have current passing through here. Then let's have current passing through here as well. And we see we have this voltage source here, and this voltage source is going to cause this entire node to also be VOT. So let's get the impedance values for everything. So this will be 1 over JW times 0.1, and that's just so 1 over 0.1, that's just 10. So it'll just be 10 over JW, and the impedance value for that will just be JW2. So let's write the nodal equation. So we have I of t entering the node. Then we have, hold on, let's call this I1, I2. So I1 and I2, they're both leaving the node. So VO of t all over 10 plus 1 over, 10 plus 10 over JW plus I2, which will be VO of t all over 6 plus J2W, and this is all equal to I of t. So we need to, let's factor all our VO of t's. Okay, so let's see what we can do. If we divide both sides by this value, then we're going to have 1 all over I of t. So this part is in this format, but we need to bring this to the other side. So if we divide all of this over here, then we see the following is true. Okay, so this is just 1 all over all of this. So now we have the following in this format. So now what I'm going to do is pretty much try and simplify this out more. So let me see what I could do. I'm going to times this by JW. So I'm going to have 1 over JW10 plus 10 over JW times this by JW, this by JW, so this and this cancels out. So I just have the following, plus 1 over 6 plus J2W. Now I'm going to try and get common denominators. So times this side by 6 plus J2W. And then times this side by JW10. So we have the following. And recall it's to the power of -1. So what we can do is we can swap these two. Wait, so all of this is still equal to VO over I of t. But since this is to the power of -1, we can swap this, put it up here, and take this and put it down there. So let me quickly do that. So it'll be jw10 plus 10 times 6 plus j2w all over jw6 plus j2w plus jw10 plus 10. Okay, now I'm going to FOIL this jw into here. So this is just going to be j6w plus, so j times j, that's -1. So minus 2w squared. So I'm just going to put that into here. j6w minus 2w squared. Okay, and I can add these two up. So it'll be 16. Alright, looking good so far. Now what I'm going to do next is factor out a 10 from all of this, and then factor out a 2 from all of this, and then factor out a 2 from all of this as well. Okay, so this and this cancels each other out. So now we're just left with the following. Okay, now notice this w squared here, sorry, minus w squared here. This is actually the same thing as the following. These two are actually the same thing, and we want it to be in this representation. Then we can have a nice quadratic for us to work with, because right now we can't really factor this because this is missing a j, but we can rewrite it like this because this will just be j squared times w squared, which will be minus w squared. So we'll just replace this with jw squared. Now let s equal jw. So this will be 10 times s plus 1 times 3 plus s all over s squared plus 8s plus 5. Now we can get our 0 values. So s is going to be -1 and s is going to be -3. That's when this whole thing becomes 0. And then to get our poles, it's when this part is 0, or when this whole thing becomes undefined. So we can't really factor this, but we can use the quadratic formula. And then we should get 2 pole values. So let me see what I get. So I get minus 1.3667. Wait, sorry. Wait, hold on. Let me try that again. Sorry, minus 0.68337. I forgot to divide it by 2. And we also get minus 7.3166. So these are your poles and these are your